Vector equation of a plane in parametric form. First thing to note is that this is a vector equation when it's in parametric form. So when you talk about vector equation, it's important to say whether you're working in scalar product form or in the parametric form, which is given at the bottom here, and we'll explain that as we go through this lesson. We want to be able to describe the position of a general point R on the plane from the origin. So let's say we've got some point on the plane, some general point here, R. We can get onto the plane using the vector A. So A, as usual, is a known point on the plane with position vector A. So the vector A goes from O to a known point on the plane. Once we're on the plane, we can move to any point on the plane using scalar multiples of the vectors B and C. We can see that B and C are vectors in the plane. And as long as those vectors are not parallel, then we can move to any point on the plane, for example, by doing 2B plus 1C would take us to this point from A. And clearly we can change the 2 and we can change the 1 in front of the C. And just like coordinates work on an XY plane, we can get to any point which is on the plane using this system. So the way we write that is that R, that's the position vector of a general point on the plane, is equal to A, so that gets us onto the plane, and then we have scalar multiples of B and C moving us around the plane.